हेलो एवरीवन एंड वेलकम टू विद्यालंकार। माय नेम इज़ अनुज पवार। और जैसे कि हमने लास्ट सेशन में देखा था कि गेट की रिगार्डिंग इंपॉर्टेंट सिविल इंजीनियरिंग की रिगार्डिंग कौन कौन से सब्जेक्ट्स हैं और उन सब्जेक्ट्स में से कौन कौन से इंपॉर्टेंट चैप्टर्स हैं। सो आज के सेशन में हम उसी एक सब्जेक्ट के साथ स्टार्ट करेंगे, जैसे कि सॉइल मैकेनिक्स। ये सिविल इंजीनियरिंग का एक वास्ट सब्जेक्ट है जिसका वेटेज ऑलमोस्ट 16 टू 17 मार्क्स का है। सो इन दैट हमने 7 चैप्टर्स लिस्ट आउट किए थे, उसमें से आज हम एक मॉड्यूल देखेंगे जो कि है कंसोलिडेशन। तो जैसे कि हमें पता है कि हर बार कंसोलिडेशन चैप्टर से एक क्वेश्चन श्योर शॉट आता है जो कि 2 मार्क्स का रहता है। तो आज हम वही चैप्टर को थोड़ा सा रिवाइज करेंगे और कुछ प्रीवियस ईयर्स के कुछ न्यूमेरिकल्स लगाएंगे एंड ये साल कौन कौन से न्यूमेरिकल्स के टाइप्स आने के चांसेस है वो भी डिस्कस करेंगे। फॉर मोर इंफॉर्मेशन एंड अपडेट यू कैन सब्सक्राइब अवर चैनल एंड यू कैन क्लिक ऑन द बेल आइकॉन। सो विथ स्टार्टिंग विद दिस चैप्टर, फर्स्ट हमें ये पता रहना चाहिए कि ये चैप्टर में से कौन कौन से फॉर्मूलेज जो हमें यूजेबल हो सकते हैं। फर्स्ट वन हमें ये पता रहना चाहिए कि कौन कौन से कोएफिशिएंट्स जो कि कंसोलिडेशन चैप्टर में हमें यूजेबल रहेंगे। फर्स्ट कोएफिशिएंट है आपका कोएफिशिएंट ऑफ कंप्रेसिबिलिटी, जिसे एवी से डिनोट किया जाता है। दैट इज नथिंग बट चेंज इन वॉइड रेशियो बाय चेंज इन इफेक्टिव स्ट्रेस। सेकेंड कोएफिशिएंट है कोएफिशिएंट ऑफ कंप्रेशन इंडेक्स, जो सीसी से डिनोट किया जाता है। दैट इज चेंज इन वॉइड रेशियो with respect to logarithmic change in effective stress. So here you have to take the logarithmic part for this denominator so that जो आपका लाइन ड्रॉ करोगे आफ्टर प्लॉटिंग the void ratio versus effective state, that curve you will get in a linear form by just taking this term in terms of logarithmic. The another coefficient is called as a coefficient of recompression. The formula will be same as the coefficient of compression index only. Just the difference is that coefficient of compression index will be used when your soil is a normally consolidated soil, and the coefficient of recompression index will be used when your soil is over consolidated soil. The further you must know also the one more coefficient, that is the coefficient of volume compressibility, which is denoted by the letter as m suffix v and which is given as AV upon 1 plus E naught. As AV we have already seen, that is coefficient of compressibility, and the one more coefficient that you can remember, that is a coefficient of consolidation CV. That CV is given as K divided by mv into gamma w. So Co is a coefficient of permeability, mv is a volume compressibility, and gamma w is a unit weight of water. So this y coefficient you must know at the time of solving the numerical. That is the first part, that is first task, that 5 coefficients you must know. The second task, you must know the time factor. That time factor TV is equals to CV into T by D square. So that time factor is given as a coefficient of consolidation, the time required for the settlement, and D stands for the drainage path. So it may be either one way or two way, that we'll see in the numericals. The third part, you must know how to calculate the degree of consolidation. That is a ultimate fraction of the, you can say, the expulsion of water which is taking place from the start of the consolidation and the end of the consolidation, and which is generally there are 3-4 formulas, but most probably the used formula will be small delta H by capital delta H. Small delta H is nothing but the settlement at any time t, and capital delta H nothing but the ultimate settlement. मतलब consolidation जब खत्म हो जाएगा तब का settlement जो रहेगा वो capital delta H रहेगा. So this is the third formula, and the fourth one will be that is finding out the ultimate settlement for a primary consolidation. So for that there are 3 formulas which is given. That first one is, that is delta H by H naught is equals to change in void ratio upon 1 plus initial void ratio. That is one part. Second formula you can take as a delta H is equals to mv into unit weight of water, mv into change in effective stress into H naught, and the last formula will be used as a delta H is equals to Cc into H naught upon 1 plus E naught log to the base 10 of initial stress plus change in stress upon initial effective stress. So these are the three formulas that you can use to find out the settlement. So that capital delta S stands for the settlement. So if you have to find out the settlement, ultimate settlement, you can use either this formula, that is with respect to the height of the you can say the clay layer and void ratio. Secondly, if you know the volume compressibility, then you can use this one, and if you know the coefficient of compression index, then you can go with this one. So using this formula list, we will start with the numerical one by one. So the first numerical, so in the 2020 in the morning slot they will be asked a field of 2 meter sand जिसका यूनिट वेट उन्होंने दिया है 20 किलो न्यूटन पर मीटर क्यूब. The placed over a clay layer to accelerate the consolidation. So coefficient of consolidation they have given here as a CV value, and the volume compressibility also they have given, and they have asked us to find out the settlement of the clay layer after the 10 years. So they have not asked to find out the ultimate, but before that they have asked. So first for that we must know that how to find out the settlement. So with the given data, what we'll do, we'll first find out the ultimate settlement. So for that, finding out the ultimate settlement, if you'll see here, the MV is given. So using the MV, we can find out that settlement, that ultimate settlement delta H is equals to MV into H naught into change in effective stress. So MV they have given here as a 2.2 into 10 power minus 4 into H naught, the thickness of the clay layer. So thickness of the clay layer, if you'll see here, it is a 10 meter, so this will be 10, and change in effective stress. So whatever the field we are adding, that will be the change in stress. So that is given as a 2 meter field and having the unit weight as a 20. So it will be your 2 into 20. So which gives me the settlement in terms of meter, and that value is coming to be 0.088 meter, which is also equivalent to the 88 mm. So here we have find out the ultimate settlement, मतलब पूरा consolidation होने के बाद ये मेरा settlement का value रहेगा. But they have not asked to find out the ultimate settlement. They have asked here to find out the settlement after 10 year. So 10 साल के बाद कितना रहेगा वो हमें settlement निकालना है. For that we'll use the time factor theory. So we know that TV is equals to CV into T by D square. So if you observe here, the time factor is unknown, so that we have to find out. CV value they have given, the time duration that is 10 years, that is also known, the drainage path. So if you see here drainage path, we are finding out the settlement of this clay layer, and if you see here, the above portion and the below portion of the clay is a permeable one, as clay below is a sand and above itself is a water table. So both are the permeable one. It stands for your drainage path will be two-way. So whenever the drainage path will be two-way, your D is nothing but H by 2. So that half of the portion will travel on this side and half of the portion will travel on this side. So here you can find out TV is equals to CV, as we know, that is given as a 9 into 10 power minus 2, which is given in terms of meter square per year. The time duration also will put in terms of years, that is 10 years, divided by D square. So D square यहाँ पे drainage path, if you will see that this will be H is 10, 10 divided by 2, that is 5 meter. So it will be as a 5 square. So if you solve that, you will get the value for the time factor. That time factor is coming to be 0.036. So with the help of the time factor, you can find out the degree of consolidation. As we know that time factor is nothing but pi by 4 u divided by 100 bracket square. So this is a relation between the time factor and degree of consolidation. You can refer our formula list, in that you can see how that come. And as we know that TV is known, that is 0.036. So if you put here as a 0.036, you will get the value of degree of consolidation, that is a percentage U, that is coming to be 0.214. So ये हमारा degree of consolidation आया है. So with the help of the degree of consolidation, you can find out that percentage U is equals to small delta H by capital delta H. So यहाँ पे small delta H हमें find out करना है. उन्होंने पूछा है कि 10 साल बाद कितना settlement होगा, तो ये हमें find out करना है. Ultimate settlement हमने already find out किया है, ये 88 mm है. Degree of consolidation for the 10 years we have find out, that is 0.214. सो इससे यहाँ पे अगर मैं परसेंटेज ऑफ यू का वैल्यू एज ए 0.214 पुटअप करता हूँ, स्मॉल डेल्टा एच दैट वी हैव टू फाइंड आउट, कैपिटल डेल्टा एच इज 88. So with the help of that you can find out that settlement after the 10 years is coming to be 18.84 mm. So this will be the your final answer for this question. So we'll move on to the our next question. That second question is given as, in audiometer test the initial depth of the soil sample is 19 mm. So basically they have given the initial thickness or H value as 19 mm. Second one, they have given the reduction in a depth is 2.1 mm after the application of load. So ultimately they have given the settlement. So delta H they have given here as a 2.1 mm. The final void ratio is 0.62. So I am taking as a final void ratio as EF, or you can say as E1 also, that is 0.62, and they have asked us to calculate the initial void ratio, that is E0. So using the two formula here you can find out the first one. As we know that delta H by H naught is equals to change in effective stress upon 1 plus E naught, and another formula also we know that delta H upon H naught is equals to Cc upon 1 plus E naught log to the base 10 initial stress plus change in stress upon initial stress. But यहाँ पे आप ये सिंगल फॉर्मूले से भी फाइंड आउट कर सकते हो. सो यहाँ पे मुझे डेल्टा एच का वैल्यू पता है, दैट इज 2.1 mm डिवाइड बाय एच नॉट का वैल्यू, दैट इज थिकनेस ऑफ द सैंपल, जो कि आप एच भी बोल सकते हो, दैट इज 19 mm, इज इक्वल टू चेंज इन वॉइड रेशियो. चेंज इन वॉइड रेशियो इज नथिंग बट इनिशियल वॉइड रेशियो माइनस फाइनल वॉइड रेशियो. सो इनिशियल वॉइड रेशियो वी नो दैट, फाइनल वॉइड रेशियो वी नो दैट, इनिशियल वॉइड रेशियो दैट वी हैव टू फाइंड आउट, and 1 plus initial void ratio. So if I will put here as a final void ratio value as 0.62, the only unknown is initial void ratio. So we can find out the value for the initial void ratio, which is coming to be 0.821. For a cross checking, you have to see that your initial void ratio value must be more than your final void ratio. As we are applying the load, definitely your void ratio reduces. So this will be your second numerical which is asked in the 2020 for the 2 marks. The third numerical, if you will see here, the construction of a new building which is founded on a clay soil was completed in January 2010. So basically building construct किया है कितने कौन से साल पे, Jan 2010 पे complete किया है. In January 2014, so January 2014 में मतलब 4 साल बाद the average consolidation settlement was recorded as 10 mm. So basically whenever you are measuring the settlement in between the starting period and the end of consolidation, you can denote by the small delta h. So that is given as a 10 mm. They are also given here as a ultimate consolidation settlement. So ultimate consolidation matlab capital delta h, which is given here as a 40 mm. Now they have asked here, assuming that the double drainage path, what will be the consolidation settlement in January 2019? So January 2019 में कितना सेटलमेंट होगा ये उन्होंने यहाँ पे पूछा है. अगर आप टाइम स्पैन के लिए एक मैं लाइन डायग्राम ड्रॉ करता हूँ, तो बेसिकली यहाँ पे ये किया है कि 2010 में मेरा बिल्डिंग कंस्ट्रक्ट हुआ है, 2014 पे अगर मैं देखता हूँ तो वहाँ पे मुझे सेटलमेंट जो मिला है वो 10 mm मिला है. कहीं पे जहां पे आपका डिग्री ऑफ कंसोलिडेशन 100% है, आपका कंसोलिडेशन पूरा हो चुका है, वहां का अल्टीमेट सेटलमेंट उन्होंने दिया है 40 mm दिया है. एंड दे हैव आस्क्ड इन बिटवीन दैट, अगर 2019 की बात करेंगे तो वहां पे मुझे सेटलमेंट कितना मिलेगा वो उन्होंने फाइंड आउट करने के लिए हमें बोला है. सो हम क्या करेंगे, फर्स्ट विद रिस्पेक्ट टू दिस 2010 एंड 2014 डाटा विल कैलकुलेट द कोएफिशिएंट्स. सो जैसे कि यहाँ पे अगर देखोगे तो फर्स्ट आपको फाइंड आउट करना है, दैट इज डिग्री ऑफ कंसोलिडेशन, दैट इज स्मॉल डेल्टा एच बाय कैपिटल डेल्टा एच. सो फॉर द 2010 टू 2014 के लिए अगर देखोगे तो इट विल बी 10 डिवाइडेड बाय 40 which is coming to be 0.25, and for that 0.25 you'll find out the time factor, that is TV is equals to pi by 4 into u by 100 ब्रैकेट का स्क्वायर. सो अगर यहाँ पे आप परसेंटेज u का वैल्यू डालते हो और टाइम फैक्टर निकालते हो, दैट टाइम फैक्टर इज कमिंग टू बी near around 0.04908. So as we know that TV is equals to CV into T by D square. सो यहाँ पे ड्रेनेज पाथ उन्होंने डबल ड्रेनेज लेने के लिए बोला है, तो डबल ड्रेनेज जब भी लोगे तो आपका ड्रेनेज का वैल्यू क्या रहेगा, h0/2 रहेगा। तो यहाँ पे टाइम फैक्टर मुझे पता है, दैट इज 0.04908 इज इक्वल्स टू CV अननोन है, आई विल राइट इन टर्म्स ऑफ अननोन टर्म्स। टाइम ड्यूरेशन मुझे पता है 2010 to 2014 के लिए टाइम ड्यूरेशन है मेरा 4 years, डिवाइड बाय द ड्रेनेज पाथ आई विल कीप एज h0/2 ब्रैकेट का स्क्वायर। सो यहाँ पे मैं एक फैक्टर निकाल लेता हूं, जो कि मैं किसके टर्म्स में निकाल रहा हूं, CV/h0 के टर्म्स में निकाल रहा हूं। तो वही CV/h0 के टर्म्स में विल पुट व्हेन वी आर यूजिंग द जनवरी 2019। सो अगर मैं सेकेंड केस की बात करता हूं, फ्रॉम 2010 टू 2019 की अगर मैं बात करता हूं, तो टाइम का स्पैन है आपका टोटल 9 ईयर्स का। तो यहां के लिए अगर मैं फॉर्मूला लिखता हूं, TV इज इक्वल टू CV इंटू T/d²। सो एज CV/d² जो कि आपका h0/2 है, वो ये जो भी कोएफिशिएंट आएगा, आई विल पुट दैट टाइम ईयर्स, आई विल पुट हियर एज 9 ईयर्स एंड आई विल फाइंड आउट द टाइम फैक्टर। सो आई विल वर्क आउट इन रिवर्स वे। सो इफ यू सी हियर द टाइम फैक्टर, इफ आई टू फाइंड आउट द CV/d² का वैल्यू मैं पुटअप करता हूं, जो कि ये कोएफिशिएंट सॉल्व करने के बाद आता है, इट इज 3.067 into 10⁻³ into the time duration, as we know that, so time duration is 9 years, so here is 9 years and it is h0/2 bracket square, so ये 2 square ऊपर आएगा तो it will become as a 4. So with the help of that you will get the time factor as a 0.1104. So as we know that TV, so with the help of TV you can reverse way you can find out the percentage U. So same way if you will see here, परसेंटेज यू निकालना है तो सेम फॉर्मूला ये वाला यूज करेंगे, दैट इज अ TV इज इक्वल्स टू π/4 इंटू U/100 का स्क्वायर। सो यहां से आपका परसेंटेज यू का वैल्यू आएगा, परसेंटेज यू वैल्यू इज कमिंग्स टू बी 0.375 एंड एज वी नो दैट परसेंटेज यू इज नथिंग बट स्मॉल डेल्टा एच बाय कैपिटल डेल्टा एच। सो परसेंटेज यू इज 0.375, स्मॉल डेल्टा एच दैट वे टू फाइंड आउट, दैट इज आफ्टर द 9 years, कैपिटल डेल्टा एच वी नो दैट इज 40 mm। सो यहां से आपका स्मॉल डेल्टा एच मतलब सेटलमेंट आफ्टर 9 years, दैट इज इन जनवरी 2019 निकल आएगा, विच इज कमिंग्स टू बी 15 mm। सो दिस विल बी योर फाइनल आंसर फॉर दिस क्वेश्चन नंबर 3rd. Moving on to the next question, that is question number 4. So it is asked in 2018 for 2 marks. They have given here the void ratio of the soil is 0.55 and the effective normal stress given as a 140. The compression index is 0.25. So basically E0 is given here as a 0.55. The stress, initial stress, you can say it is given as a 140 kPa, and the CC value, coefficient of compression index, they have given as a 0.25. Now the void ratio is reduced and void ratio जो final है that is given as 0.4, and they have asked what is the increase in the magnitude. So basically they have asked the change in stress, effective stress they have asked. So for that you can use two simultaneous equation. So first will be your that corresponding to the delta H by H0 is equals to change in void ratio upon 1 plus void ratio, and second one will be delta H by H0 is equals to Cc upon 1 plus E0 log to the base 10 of initial stress, effective initial stress plus change in effective stress by initial effective stress. So as here initial effective stress we know that, change in effective stress we have to find out. If I will equate these two, so my equation will become as a change in void ratio upon 1 plus void ratio is equals to Cc upon 1 plus void ratio log to the base 10 of initial stress plus change in effective stress by initial stress. So these two terms will get cancelled. So change in stress, that is we know that E0 minus E1, that is 0.55 minus 0.4. Cc यहाँ पे लेके आता हूँ डिनोमिनेटर में हो जाएगा, कोएफिशिएंट ऑफ कंप्रेशन इंडेक्स है 0.25 is equals to log to the base 10 of initial stress is your 140, change in effective stress we have to find out, and initial effective stress is 140. So there is only unknown will be your change in effective stress. If you will solve that, you will get the answer as a 417.85 kPa, kilopascal, that is kilonewton per meter square. So this will be your question number 4, which is asked for the 2018 for 2 marks. The next question, that is question number 5, that will be given for 2 marks in 2018. In this question, the compression curve, that is actually plot which is semi logarithmic पे plot किया गया है, and that will be curved like this one. If you'll recall the terms, that will be your logarithmic effective stress versus void ratio, and they have given here the initial void ratio as a 1.2 and the initial effective stress as a 50 kPa, and final void ratio they have given as a 0.6 and the final effective stress they have given here as a 800 kPa. So with this data they have asked us to find out the compression index. Compression index is nothing but Cc. So in the formula list also we have written the formula for the Cc, that is nothing but change in effective stress divided by log to the base 10 of final effective stress by initial effective stress. So if we know that change in void ratio, that is 1.2 minus 0.6 divided by log to the base 10 of final effective stress is 800 divided by initial effective stress is 50. So if you will solve that, you will get the value as a 0.4982. So they are here asked for up to the 2 decimal. So here you have to round up the formula. So you can here is a round up to the 0.50. That will be your coefficient of compression index. So it is a simple formula that you have to use here. Make sure that you must use the proper virtual calculator here. And we'll take one more last numerical which is from the 2017. So in the 2017 the question is asked, the 3 meter thick clay layer is given, having the uniform pore pressure of 145 they have given, the coefficient of consolidation CV value here they have given as a 3 mm square per minute, and the time factor for the 90 degree they have given here as 0.85, and the term they have asked for the given ground condition, the time in days which is required for 90% of consolidation. So basically here we have to find out the time, जो कि हमें किस में पूछा है, days में पूछा गया है. So हमें time निकालना है, तो definitely we have to work on with the time factor. So time factor का formula है TV is equals to CV into T by D square. So ये T जो है वो हमें निकालने के लिए बोला है. As TV for the 90% that is already given, that is 0.85 is equals to coefficient of consolidation is also given, that is 3, that is in mm and minute. So make sure that rest other parameters also will get in terms of mm and minutes में ही आपको put up करने हैं. Time duration I will keep as unknown. D is a drainage path. If you will see that this will be permeable, above is sand, but bottom will be the impermeable. So यहाँ से ये आपका पानी permeable नहीं रहेगा, इसलिए आपका drainage path जो है वो क्या हो जाएगा, one way हो जाएगा. So one way होता है तब आपका ड्रेनेज पाथ का वैल्यू इटसेल्फ एज एच नॉट वैल्यू जो कि आपका यहाँ पे 3 मीटर रहेगा. बट एज द कोएफिशिएंट ऑफ कंसोलिडेशन वी हैव पुट अप इन टर्म्स ऑफ mm, सो ये ड्रेनेज पाथ भी हमें किस में पुट अप करना पड़ेगा, mm में करना पड़ेगा, जो कि आपका कितना हो जाएगा 3000 mm, जिसका आपको d स्क्वायर लेना है इसलिए इसका स्क्वायर लिया है. सो जो आपका टाइम आएगा दैट इज कमिंग्स टू बी 255.1234 मिनट्स. ये मिनट्स में आ रहा है बट दे हैव आस्क्ड इन टर्म्स ऑफ डेज. सो डिवाइड बाय 60 एंड डिवाइड बाय 24 करोगे तो आपको टाइम आ जाएगा नियर अराउंड 1770 डेज. सो दिस विल बी द आंसर फॉर दिस क्वेश्चन. सो व्हाट वी कैन कंक्लूड हियर फ्रॉम द consolidation chapter, it is expected numerical in this year, that is 2021. Either they will be asked based on the compression index, either the formula or the numerical will be asked from the time factor, you have to find out the time duration, and either they will ask from the primary consolidation, that is finding out the delta H. So ये तीन में से इस बार एक क्वेश्चन आने के चांसेस है which gives you the 2 marks. So basically refer the formula list, properly use all these coefficients, time factor, degree of consolidation and primary consolidation निकालने के लिए जो तीन formulas हमने in the initial first second slide में देखा है formula list में, वो देखो and you can go with that. अगर आपको किसी भी तरह की query आती है आप नीचे comment section में डालो, will solve that query. So if you like this video, you can like, you can subscribe and you can click on the bell icon. Thank you very much.